OpenMP. OpenMP is an API for writing multi-threaded applications. It is based on a set of directives, runtime routine, and environment variables. Let me give you an example. So here are the kind of directives you can have. Okay, so it specifies that this has to be executed in parallel, and this is an example of runtime routines to get the ID of the threads, or to get, for instance, the number of threads that are available. What is important to note is that in here I have the equivalent of a join operation, and here I have an equivalent of a fork operation. Directives has been used for a very long time, and in particular they were used already on the Cray machine, one of the first supercomputers in '78. The directives, they talk to the compiler. Okay. So they specify some data or some commands that will drive the code generation process. One of the advantages is frequently they can be ignored. So the approach behind OpenMP is first to target shared memory machines. So you need to have a shared memory to get OpenMP to work. The idea also behind it is to have an incremental parallelization process. So you add directives to your code, get some piece of code running in parallel, and then you can add more. It's available on many platforms and compilers, so most of the multi-core support OpenMP, and it's available in C, C++, and Fortran, so on multiple languages. There is one thing you need to be careful with, is that the OpenMP directives may break the program semantic. In some sense, the compiler doesn't verify if the code you're specifying as being a parallel piece of code is really parallel. So if you ask the compiler to run in parallel some piece of code, it will do that, and if it's not a really parallel piece of code, it won't work. So the main operations are in the parallel model are fork and join. So you create threads to execute some piece of code. You start with the sequential regions, and you can have nested parallelism. So inside a parallel regions, you can also create new parallel regions. And all that depends on the availability of shared memory, and this is how you will exchange data between threads. The computing stack, you have the machine, you have the OS, you have the OpenMP runtime libraries that will manage the threads and allocating the work on the threads, the OpenMP libraries to provide you the runtime API, and you have the compilers that will take the directives into the code to generate the parallel code. And you have some environment variables that you can use to specify, for instance, the number of threads, etc. The basic syntax is as follows. You have some pragma, OpenMP, and here you add the constructs, the OpenMP construct you want to use. Usually it applies to a block of statements. And there is an implicit barrier here and here at the beginning and at the end of the block. So if you have two blocks that follows, it will execute first the first block and then the threads corresponding to the next block. In C, you need to add an include file to get access to the runtime API. If we take this example again, okay, when I specify parallel regions, I need to specify the private variables, otherwise I will have only one copies for all the threads, so of course that won't work. Okay, and these variables, so I need a local copy for each thread, and if I have 3 threads in my system, there is some default numbers that is set when you start an OpenMP program, but you can change that number through variables or through a call to the API. You will run 3 times that. And because my task access to global variable and modify global variable, I ask only to the first thread TID to do the work, not the master thread, the next one. And here I measure the time. For the memory model, all global variables are shared among threads. Okay, so that's the default. So every time you have shared variables that are modified by different threads, you have to be very careful. Either you add locks, or you have to add some mechanism to protect the access to the shared variable. What is private by default is all the stack variables. So when you have created a block and you put variables there, declaration of variables there, they are private. And everything that is in subprograms called from the parallel regions are also private. So the questions for this part of the course is compare the pthread implementation with the OpenMP implementation. What is your opinion on that, and what properties do you see for each cases? And another question is, what is the issue with this code? This code is incorrect. What is the bug there? Some references, some books, and you can look at the openmp.org website. See you in class.